Welcome, grade 11. We're busy with analytical geometry, and our lesson today will be looking at the inclination of a line. The inclination of a line is the angle that the line forms with the x-axis. But it is important to take note that that angle of inclination should be on the positive end of the x-axis. The angle definitely should be sitting on the x-axis. Like if you look at these two diagrams, theta is sitting on the x-axis, and theta should be on the right side of the line. Remember that we measure angles starting from 0 degrees. So your x-axis is at 0 degrees. And to measure the angle of inclination, you're going to measure from 0 degrees in an anti-clockwise direction. That is how we get theta for the first part there. Similarly, for this one here, the x-axis is at 0 degrees, and we are measuring in an anti-clockwise until we get to the line. So we need to rotate through that angle of theta degrees. Now in these two diagrams, the first diagram has a positive gradient, and the second diagram has a negative gradient. There is always a connection between the inclination of the line and the gradient of the line. And the relationship is given by this formula, tan theta is equal to m. So we will be using that formula to work out the angle of inclination. So necessarily we need to know m in order for us to find the inclination of the line, because tangent of the inclination will always be equal to the gradient of the line. Right, if your line has a positive gradient, then the angle of inclination will be acute, and that means the angle will lie between 0 degrees and 90 degrees. If the line has a negative gradient, then the inclination will be obtuse. So theta will lie between 90 degrees and 180 degrees. Let's look at one example. We are given, in this case, the line 3x minus 2y is equal to 6. And we are looking for the angle of inclination. Remember, we are using the formula tan of theta is equal to m. So we need to work out the gradient of this line. And the best way to work out the gradient of the line is to rearrange that equation there and write it in the form y is equal to mx plus c. Then we can take m there to be the gradient. So let's do that. So this is 3x minus 2y is equal to 6. And so rearranging that will give you minus 2y is equal to minus 3x plus 6. And dividing by negative 2 both sides will give you y equals 3 over 2x minus 3. So the gradient of the line is 3 over 2. Now put that into the formula. Tan of theta is equal to 3 over 2. And to find theta, use your calculator, shift tan, you just write it as it is, shift tan of 3 over 2. All right, and that will give you your angle of 56.3 degrees. Please just take note. Make sure that your calculator is in degree mode. Otherwise, you won't get that answer there. Right, here's another example. In this case, our line passes through 2 points, minus 3, 5, and 5 minus 3. So the first thing is obviously to work out the gradient, because we cannot find the angle of inclination if we don't know the gradient of the line. So let's find the gradient. In this example, the gradient will be equal to y2 minus y1 divided by x2 minus x1. So it's 5 subtract negative 3 divided by negative 3 subtract 5. And that will give you a minus 1. So the gradient of the line is equal to negative 1. All right. If you look at the line there, our angle theta is obtuse. And we said earlier on, a negative gradient will actually give you an obtuse angle. And this is what we are looking at now. Now let's use the formula tan theta is equal to m. So now that means tan of theta should be equal to -1. And you work out theta using your calculator, shift tan of -1. But what will happen is if you shift tan negative of 1, the answer you get there is -45. Right, and -45 cannot be that angle theta that we want to find. -45 is actually this angle here. Remember, negative angles are actually obtained by measuring in a clockwise direction. But for the angle of inclination, we are measuring in an anti-clockwise direction. All right, so that -45 that you get is that angle there. But we are looking for theta, not -45. And clearly, this is a straight line. The angles on a straight line should add up to 180. So all you need to do to that -45 is to add 180 degrees. All right, just add 180 degrees. That is the same thing as saying 180 subtract 45. And so you will get your answer of 135 degrees. So that angle of inclination there is 135 degrees. So if you put shift tan -1 into your calculator, you get a negative angle. That negative angle cannot be your answer. By definition, the angle of inclination should always be positive. So if you get a negative answer, just add 180 to that answer, and you will get your final answer. Right, here's another example. In this example, we are given two lines. The first line is 2y plus x, 2y is equal to x plus 4. And the second one is x plus 2y is equal to 6, that's drawn on the diagram there. And we are looking for the angle beta. So we are looking for that angle there. That is the angle that is formed when these two lines meet. Now, to find angle beta, we need to know angle theta, and we need to know angle alpha. So we need to know angle beta and angle, so we need to know angle alpha and angle theta. Right, there is a theorem that says in a triangle, the exterior angle is equal to the sum of the is equal to the sum of the interior opposite angles. So in our case, alpha is exterior, theta and beta are interior opposite. So alpha is equal to theta plus beta. So all you need to do is work out angle theta and work out angle alpha, then put that into an equation using the properties of a triangle. Obviously, some of you may prefer to say, because you know alpha, you can actually work this one out. You can work out the interior angle. So now with this interior angle and that other interior angle, those two can be added together and the answer subtracted from 180 degrees. And that will give you beta. So that is why I worked out the gradient of this line. This is my line 1, and this is my second line. And so rearrange this equation, you will get the gradient equal to half, and then put that into tan theta is equal to m, you will get theta is equal to 26,57. So this angle here is 26,57. Right, so this is 26,57. So you need to work out the angle of inclination. And this angle alpha, the gradient of this line, line 2, right, the gradient of line 2 will be -half. And you put that into your calculator, shift tan of -half, you will get a negative answer. Then add 180, and so you get your angle alpha equal to 153,43 degrees. Right, and then you apply the theorem that says the exterior angle alpha is equal to the interior, is equal to the sum of the interior opposite angles. So alpha is 153,43 degrees, and this is equal to theta plus beta, but theta is 26,57 degrees plus beta. Solve that for beta, you should get 126 86.